In this video, we're going to be solving systems of equations algebraically. So we've already done it graphically. This time we're going to look at doing it both by substitution and by elimination. So when we solved by graphing, you remember that the answer was the point of intersection. Remember, the blue points, every point on there makes that blue equation true. The red points, every point on there makes the red equation true, and that black point makes the blue one and the red one true simultaneously. So that is the answer because it makes both equations true. And the answer is a point, x comma y, in this case 3 comma 1. Okay, so let's do this one. Y equals 2x minus 5 and y equals negative 1/3 x plus 2. If I wanted to, I could graph this. They're both in a good form to graph, but I'm going to choose to do it by algebra because that eliminates the possibility for a lot of graphing errors. All right, here I have y equal to 2x minus 5, and here I have that same y, but this time it's equal to negative 1/3 x plus 2. So if I want to substitute, it means I can replace this y with negative 1/3 x plus 2. Y and negative 1/3 x plus 2 are the same thing, so I'm going to choose to replace that up there. Okay, so I'm going to get negative 1/3 x plus 2 equals 2x minus 5. All right, it would be nice when I solve this if I didn't have to worry about those fractions. So let's distribute a 3. That's your common denominator. In this case, it's your only denominator. But let's distribute that 3 across there so I can clear out the fractions. Negative 1/3 times 3, that's negative 1. Now keep going across. 2 times 3 is 6. All right, now to this one. Again, 2 times 3 is 6. This time it's 6x. And here, 5 times 3 is 15. Okay, let's see what we can do to solve for x. I'm going to get all my x's on the same side, so I'm going to add 1x on both sides. 1x plus 6x is 7x. I'll add 15 to move it away from the x, and I get 21. Now, x. I'll divide both sides by 7. X equals 3. So it might be tempting at this point to think you're done, right? You have x equals a number, so you should be done. But remember, what we're doing is we're solving this system of equations, and the answer to the system of equations is a point. Point has x and y, and I only have x so far. So that means I need to find a y. So I'm going to take that x. I can substitute it into the first one or the second one. It doesn't matter. I'll get the same answer both ways. I'm going to choose the first one. So I'll substitute in 3 for x. 2 times 3 is 6. 6 minus 5 is 1. So the answer to my system of equations is the point 3 comma 1. That's actually the system that I graphed on this slide. The two lines crossed right there at the point 3 comma 1. So if I wanted to check this, I could check it by graphing. I just checked on my graph there. I could also check this one by substitution. So it makes both equations true. So I would have to substitute into both of my equations. So I'll substitute into the top one, and then I'll substitute into the bottom one. And if it doesn't make both equations true, I'll know I made an error. So here, 2 times 3 is 6. 6 minus 5 is 1. That one's good. Negative 1/3 times 3, we already said that's negative 1. Negative 1 plus 2 is positive 1. So that one is good also. So I know I got it correct. My answer is the point 3, 1. All right, let's do this one. This one I might not want to choose to graph. They're not in the right form. These are both in standard form instead of in slope-intercept form. And so I want to try to get one variable by itself. Now, unlike what we did when we were graphing, I don't necessarily need to get y by itself. I could get y or x. It doesn't matter. I want to pick the one that has a coefficient of 1 or negative 1. In this case, that y right there has a coefficient of negative 1, so that's the one I want to pick. I'm not picking it because it's y. I'm picking it because it has a coefficient of negative 1. All right, let's work to get that y by itself. All right, so I've got negative y, and I'll divide across by negative 1, still working to get y by itself. So y equals 4x minus 3. Okay, so now I have a variable by itself. Now I can take that and I want to substitute into the other equation. It doesn't really do any good to substitute into this equation. Everything just cancels out and I'll get 3 equals 3. What I want to have is something where I can solve with my x and my y. So I have to substitute into the other equation. So that 3x, I'm not doing anything with that right now. Putting in the 4x minus 3 in place of that y. All right, I'm going to have to distribute the 2. So 3x plus 8x minus 6. Okay, combine like terms. 3 and 8 makes 11. Add 6 to both sides. And now I'm going to divide by 11 to get x by itself. And I get x is equal to 1. Okay, again, remember what I'm trying to find. I have to find a point, and so far I only have an x coordinate, so I need to find the y coordinate that goes with it. Well, the easiest one to substitute into is this one because I already have y by itself. So I'm going to take that 1 and I'm going to substitute right here. So y equals 4 times 1 minus 3. 4 times 1 is 4. 4 minus 3 is 1. So I have the point 1, comma 1 is my answer. Okay, so let's substitute that in here real quick and see if it works. If I put a 1 in place of x and in place of y, 3 plus 2 is 5. So far good. So I'm going to put a 1 right here in place of x and a 1 right here in place of y. 4 minus 1 equals 3. So everything checks out. That is the correct answer. Okay, now I mentioned that you want to solve for one that has a 1 or a negative 1 coefficient. The reason for that is because it just makes your computations easier. You're capable of solving for anything, but suppose I chose to solve for this x here. So I would add y to both sides. All right, I need to get x by itself, so I'm going to divide by, oops, not by 3, divide by 4. So x equals y plus 3 over 4. So now when I go to substitute back into the first equation, I have to substitute this fraction, which is going to mean as I'm working, I'm going to need to get common denominators. I'm going to need to do a lot of extra steps that I don't need to do if I choose to use a 1. Because if I choose something that has a 1, I don't have to worry about the fractions. You can do it with the fractions. You can absolutely get the right answer. It's just a little bit more time consuming, so it's easier if you choose not to. All right, let's look at this one. So this one immediately I notice is different because right here I have an x squared. So this time I have a parabola, right? You guys see, remember that? The x squared makes a parabola. This one is standard form of a line. This one's the blue one. But look what happens here. Do you see that they cross twice? So when I get my answer this time, I'm going to end up with 2 solutions. I have 2 points that are on both equations, and so therefore when I solve, I'm going to get 2 answers. All right, let's do that. We're going to do this one by substitution. I've already got y by itself right there, so let's substitute that into the other equation. Remember, always substitute into the other one. Okay, so let's distribute right here. 2x squared minus 16. Okay, so now look at the kind of equation that we have. First of all, these are not like terms. I can't put them together. This one is x to the first. This one is x to the second. And I notice immediately that I have a quadratic equation. And I remember that when I have a quadratic equation, I want to make it equal to 0. And I want to put these terms in descending order. Okay, so let's do that. 2x squared will be first. 2x will be second. And if I subtract 8 from both sides, I'll get negative 24. Okay, now our first step when we're trying to solve quadratics, we want to see if we can find a GCF. So 2, 2, and negative 24 has a GCF of 2. That's going to make our computations a little bit easier because now I have smaller numbers to work with. All right, so I'm going to do A equals, B equals, C equals. A is 1, B is 1, C is negative 12. So when I multiply A and C together, I get negative 12. So I want 2 numbers that multiply to be negative 12 and add to be 1. Okay, that is going to be 4 and negative 3. So let's substitute those in there. Okay, now to save time, because I'm going to run out of time on the video if I do all of the factoring steps, I'm going to go ahead and write the answer to the factoring. Okay, and then remember we set our factors equal to 0. I'm not going to set the 2 equal to 0 because it doesn't have an x in it. Only the things with x's we set equal to 0. And so I get x equals -4 and x equals 3. Okay, so that means when I substitute in, I need 2 y values. Let's do the -4 first. So I'll put -4 squared. All right, -4 squared is 16. 16 minus 8 is 8. So my first point is -4, 8. All right, now I'm going to do exactly the same thing with 3. I'm going to substitute that in there. 3 squared is 9. 9 minus 8 is 1. So I get the point 3, 1. So that's the two different answers to my equations, -4, 8, and 3, 1. Okay, let's look at elimination. We haven't done an elimination one yet. Here's a good one for elimination. Often for elimination, look, I don't have a 1 as any of my coefficients. So I want to try to cancel out. That's where eliminate comes from. I want to try to cancel out either the x's or the y's. So in this case, I can cancel out my y's because they're opposite one another. So I'm just going to add straight down. 3x and 5x makes 8x. Positive 2y and negative 2y cancel out. 10 plus 6 is 16. All right, let's divide by 8 on both sides. And I get x equals 2, which is not the answer, right? Because I got to have a point. So I'm going to substitute that back in there, and it doesn't matter which one I substitute into. Neither one of them is really easier at this point. Working to get y by itself. Let's subtract 6 and divide by 2. So y equals 2. So my answer is the point 2, 2. I have to put an x and a y. Okay, one more. Let's look at this one. So this one, I have some x values that don't cancel out, and I have some y values that don't cancel out. So I have to make them the same. I'm going to choose to do the x's only because they're a little bit more difficult, and I want you to see what to do. So I have 5 and 2. What will 2 and 5 both go into? Well, they'll both go into 10. So if I multiply the top equation by 2, and I multiply the bottom equation by 5, 2 times 5 is going to give me 10. 5 times 2 is going to give me 10. But 10 and 10 don't cancel out. In order for it to cancel, in order for them to eliminate, the signs have to be opposite. So I can either make the 2 negative or I can make the 5 negative. It doesn't matter. I'll just choose the 5. So I'm going to distribute a 2 on the top equation. All right, and I'm going to distribute a -5 on the bottom equation, just multiplying across. Okay, now I can add, because positive 10 and negative 10, when I add those, they cancel out. There I'm going to get 17 and 51. All right, trying to get y by itself. So divide by 17 on both of those. Y equals 3. Which is not the final answer, right? Because I still need an x value in order to get my point. So I can substitute into either one. I'm just going to choose the first one. Neither one of them is really easier at this point. I'm just going to choose the first one just because. All right, solving to get x by itself. Divide by 5 on both sides. X equals 1. So my answer is the point 1, 3. And then if I wanted to check that, remember I would go back and check in the first equation to make sure it worked. And then I would have to go back and check in the second equation also. It has to make both equations true in order to be the correct answer.